Hello, this is Charlene. In this video, we're going to continue to talk about Venn diagrams, but specifically, we're going to be talking about complements and intersections and unions. Here is a lot of information about these concepts. There's some definitions and things. At the top, we have the complement of set A. We have the intersection of two sets. We also have the union of two sets. Here are two visuals of what an intersection and a union looks like. And then we have more information about different kinds of complements. A complement of the intersection of two sets and the complement of the union of two sets. We are going to focus primarily in this video on these three at the top of this list because this will provide the foundation for understanding all of the rest of this information that we were given. But I definitely think it is of value to go back and read through this. We got De Morgan's laws, which is not the intersection of A and B and not the union of A and B. And this kind of explains that. But like I said, for the purposes of this video, we are going to concentrate on these three, which will provide the foundation for all the other information provided on this screen. Okay. Okay. The first concept we want to talk about is the complement of a set. We're talking about complements of sets. We're talking about intersection of sets and union of sets. Those sets can be visually represented with Venn diagrams. Okay, so the first symbol that we're going to use for a complement is A prime. Some books and textbooks, websites will use A with a line over the top of it. For the purposes of this video, our textbook tends to primarily use A prime. But another way to think about that symbol is simply to think of it as not A. So A prime is going to be the set of all the elements that are not in set A. So that means if we have a universal set with a lot of different options, whatever is set A will not be included in the complement of A. Another way to think about that is that it is the balance. They will add up to the whole. We're going to talk about this a little bit more in depth in just a few minutes. Okay, so the intersection of two sets is denoted by the symbol A intersected with B. It looks like an upside down U, but you can also think about this as and. So this helps me to remember this. This looks like it's an upside down U, but it also looks like an A that does not have the line in it. So this symbol is about and. It is about set A and set B. And the way that we can think about that is that the members of the set that is the intersection of A and B, those elements will be in both sets A and B, and they will overlap. And it will also typically be a smaller area. So the intersection of two sets is going to be set A and set B, and it will be elements that are in both sets A and sets B. There will be an overlap, and it tends to be a smaller set. Okay. The third one that we want to talk about is the union of two sets. It is denoted by the symbols A and this union symbol B. The union symbol stands for or. So this looks like a U, but you should always think of it as meaning set A or set B. And how do we identify what is in set A or set B? Well, anytime I think about set A or set B, I need to think lots of choices. And so it typically will be a bigger set of elements as opposed to a smaller set of elements. It will be set A or union with B means set A or set B, and it means lots of choices. Okay, we are going to think about the word complement in a very broad, general way first. Let's say that we have a couple, and they're in a relationship, and we say that that they complement one another. That implies that they both bring different things to that relationship, but together they make a complete whole relationship. So that is a very general way to understand the word complement. But let's think of it in terms of numbers. If I have 6 and 4 and 10, well, 6 plus 4 is equal to the whole number of 10. If I have 10 plus 40, those numbers are complements to each other because they add up to 50. Okay, we would say that the 4 is the complement of the 6 because it adds up to the 10, or the 6 is a complement of the 4 because it adds up to the 10. Same thing. 10 would be the complement to 40 with respect to 50, and 40 would be the complement of 10 with respect to 50 because they add up to the whole. It is the balance. It's like if we only have 6 out of the 10, well, the balance is the 4. So now let's bring that to the idea of sets. Let's say that we have a set U. This is all the elements in this U set, the universal set. It has a 1, 2, 4, 5, 7, and 8. And then I also have a set A. Set A includes the elements 1, 4, and 5. So how would we identify the complement of set A? Well, again, we need to think about it in terms of not A. So it means it's not going to be 1, not going to be 4, not going to be 5. So what's going to be left? It's not 1, it's not 4, it's not 5. So that means that the complement of A is going to be 2 and 7 and 8. So the complement of A would be the elements 2, 7, and 8. But if you notice, if we were to add all of these elements and all of these elements, they would add up to the whole universal set. So hopefully that kind of helps you understand more completely what we mean by complements with respect to set operations and Venn diagrams. Now let's talk about the intersection of sets. A intersected with B, which means set A and set B, also means it's in both sets. There will be an overlap, and it tends to be a smaller area. So here's a visual of this. It's like this smaller area. It's in the middle. This part of the Venn diagram is in both the A circle and the B circle. So and is the key word there. Okay, so let's see what that looks like with respect to sets. So let's say that we have set A, and it is equal to the elements 1, 4, and 5. Now we have the set B. It has the elements 2, 4, 6, and 8. So we need to identify what is the intersection of A and B. A intersected with B. So it's what is going to be in both of those sets. So is 2 in both of those sets? No. Is 4? Yes. 4 is in set A. 4 is in set B. Is 6 in both sets? No. Is 5 in both sets? No. Is 8. So the only element that is in both sets A and B is the element of 4. So that would be the answer set. A intersected with B would be the set containing the element 4. Okay, let's also talk about the union of A and B. A union with set B. The key word is or. Or means we have lots of choices. The answer set tends to be a bigger set. And visually you can see if it's or, it's everything in set A and everything in set B. So it's lots and lots and lots and lots of choices. So let's think about that with respect to our sets. We've got set A contains 1, 4, and 5. I have set B is 2, 4, 6, and 8. So we want to find the union of set A and B. So the union of set A and B would be everything. 1, 4, and 5 is going to be in set A, 2, 4, 6, and 8. I do not need to duplicate elements. So the fact that 4 is in both of them, I only need to count it once. So I can go ahead and list all these. It's going to be 1 and a 2 and a 4. Just list it one time. Do not need to duplicate it. And 5 and 6 and 8. So if you notice, the union is a much bigger set. Up here, when we did the intersection, this was a much smaller set. It's an overlap. It's something in the middle of our Venn diagram, but the union is going to be lots and lots of choices. Okay, before we can identify complements and intersections and unions of sets, we first need to set up our Venn diagram. So we are going to do that. They've given us a universal set, a set A, a set B, and set C, and we are going to identify where these elements belong in terms of our Venn diagram. So the first thing that we are going to do is we are going to start in the middle. That's what we have done before. When we're setting up Venn diagrams, we always start in the middle. What is in all the sets? What elements are common to all of the sets? Well, we don't consider the universal set. The universal set is everything outside the circles and including the circles. But we just want to start in the middle, what is in all the sets, but we mean in set A, set B, and set C. So if we look for what is in all three of the sets, I've got 1, 3, 5, and 7 for set A, 1, 2, and 3, and 2, 3, 4, 5, and 6. The only thing that is in all three of those is 3. The 3 is in all three of those. So that is what is going to go in the middle of our Venn diagram, because that space in the middle, it's included in set 3. It's also included in set A, the blue circle, and it's also inside the green circle, the set B circle. So 3 goes in the middle. Okay, the next thing we're going to do is we are going to look for what is in both A and B. So now I want to look for what is in A and B, what is in A and B, and that's going to go in this little space right here. That's the space that's only A and B, but not in C. Okay, so let's see. I've got a 1. Oh, I've got a 1. And do I have a 2? Nope, I have a 3. Yes, I have a 3. And 5 and 7 is not. However, we've already accounted for the 3, because that went in the middle. So the only thing that we have to put in this space that is A and B is the number 1. Number 1 is the only thing that goes in there, because 3 was already accounted for in the middle. Okay, so the third thing that we're going to do is say, okay, so what is in both A and C? So now I'm looking at A and C. I'm looking at A and C. So what elements are in both set A and set C? 1 is not in both. 3 is, but 3 is already accounted for. 5 is actually in both of them. 4 is not in both A and C. 6 and 7, no, they're not in both. So only 5, and so that is going to go in this space right here. This is where the 5 is going to go. That space right there is included in A and C, but not in all three. So I'm going to put number 5 right there. Number 5. Okay, that number 5 looks weird. La, la, la. Number 5. There, that looks a little bit better. Okay, so the fourth thing that I'm going to do is say what is in both C and B. So now I'm looking for B and C. So B and C, that means it's going to go in this little space that is inside both the B circle and the C circle. So what is in both B and C? Well, 1 is not in both. 2 is in both B and C. 3 is, but it's already accounted for. So those are the only things. Number 2 is the only thing that belongs in this space right here, number 2. Okay, so that was the fourth thing The fifth thing that we're going to do is we're going to look for the leftover A. So the leftover A is going to be, what have we not accounted for? It's like we've used the 1, we've used the 3, we've used the 5. The leftover is going to be number 7. So number 7 is going to go over here in the part of circle A that is not overlapping with B or C. So number 7 goes in this open space in circle A because that's the leftover. Okay, so now the number 6, we're going to look for the leftover for C. So here I'm looking at C, set C, and the only thing that has not been accounted for is the 4 has not been accounted for, and the 6. These are leftover in set C. So that means 4 and 6 are going to be in this space that is only set C. Okay, so let's see if there's anything else. Our last thing is to mark all the used numbers in the universal set. So my universal set, I've got 1 has been used, 2 has been used, 3 has been used, 4 has been used, 5 has been used, 6 and 7. So there is nothing left over. So there's literally no number out here in the universal set that is not part of either set A, B, or C. So we have no number that will be listed out here in the universal set. Okay, now that we have our Venn diagram set up properly, we are now going to find each of the following sets. So the first set that they want us to find is A prime, which is the same thing as saying not A. So if they do not want us to consider A, that means that everything that is in the A circle will be completely ignored. And that means that our set will include everything outside of A. So that means that our set is going to be the set of 2 and 4 and 6. Alrighty then. The next one we're going to try to find is B prime, which means not B. So that means everything that is in the set B is going to be ignored because it's not B, and everything outside of set B will be included. 7, 5, 4, and 6. So that means our answer set is going to be 7, 5, 4, and 6. And if you notice, these do not have to be in order. It does not matter what order your elements are in. Just a note before we move forward, this symbol right here is the complement of set B. We use this symbol and we can, instead of saying the complement of set B, we can call it B prime, which is what I've been doing. I call that B prime up here. I called this one A prime. So A prime, B prime is the same thing as the complement of set B. Okay. So the next thing we are going to look for is going to be the union of set A and set B. So we have to think about, what does this symbol union mean? Well, that symbol, it's the right side up U. So the right side up U has to do with the word or, and that means lots of choices, and it will be a bigger set typically. So, or it's going to be lots of choices. We're talking about set A, we're talking about set B. So everything in set A and everything in set B. We got lots of choices. So what are all of our choices? We've got 7, 1, 5, 3, and 2. So the union of set A and set B is going to be the set of 7, 1, 5, 3, and 2. So that is going to be the answer set of the union of A and B. Okay, the next set we're going to find is the union between set B and set C. So again, we need to consider, what does that symbol mean? The union symbol. The union symbol means or, which means lots of choices, tends to be a bigger set. So we're going to look in set B, circle B, and set C, circle C. So it's going to be anything in B or anything in C. So we have lots of choices. So our answer set is going to be 1, 3, 2, 5, 4, 6. So 1, 3, 2, 5, 4, and 6. Okay, so that is the answer for B union with C. Okay, the next one we're going to look at is going to be set A intersected with set C. So again, what does that symbol mean? Okay, that is the intersection symbol, and the intersection symbol that looks like an A without the little line means and. And when we have and, it has to be in set A and in set B. It has to be in both sets, and it will be an overlap. It tends to be a smaller area. So again, we are going to look in circle A, and we are going to look in circle C, but then we are going to find the overlap. Where is the overlap between the two? So the overlap is this area right here. So that means that our set that satisfies this description, A intersected with C, is going to be the set containing the elements 5 and 3. Or you can say 3 and 5. It doesn't matter which order our elements are in. Okay, so 5 and 3 is the right answer. Okay, the next one we're going to work on is A intersected with B intersected with C. So this time we actually are dealing with 3 different sets, not just 2. But again, we still need to consider our symbol. So that is the intersection symbol. So we want to know when our sets are going to be intersected. It still means the word and. It's like, what elements are in set A and in set B and in set C? And of course, that would mean both or all. Where is it in all 3 sets? All 3 sets. And it will be the overlap between those 3 sets. So again, we can look at all 3 sets, and we know that if it's all 3 sets, we have 3 circles, it will be in the middle. It will be whatever is in the center. This little section right here is what is intersected by all 3 circles. So the only element in this set where we intersect all 3 circles, all 3 sets, is going to be the element 3. Okay. And the next one says that we are going to unite or union. Set A is going to be unioned with set B. It's going to be unioned with set C. So that, what does that symbol mean? Well, the union symbol means that it is going to be or. It's going to be in set A or in set B or in set C. It's going to be lots of choices. So that means that we are going to identify everything in all 3 circles. So all the circles are going to be included anytime we talk about or, which is the union symbol. So that means everything. So that means that's going to be actually a pretty big set, because or tends to be bigger answer sets. So our set is going to be 7 and 1 and 5 and 3 and 2 and 4 and 6. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes, that is all of our elements in all 3 circles. Okay, the next one says that we're going to do A prime intersected with B prime, or the complement of A intersected with the complement of B. So earlier, we actually found A prime and B prime earlier in this video. So A prime was 2, 4, and 6. That was the answer set for the complement of A, or not A. And 7, 5, 4, and 6 was the complement of B, or not B. So this says that we want to intersect those. And again, what does the intersection symbol mean? The intersection symbol means that it would be what is in both of those, and it has to be in A prime and B prime. So the intersection is asking us to say what is in A prime and B prime. So if we look at these two answer sets, the elements that are the same are the 4 and the 6. That is what is in both A prime and B prime. So that would be our answer set, 4 and 6. But I want to look at it with respect to our Venn diagram. If we go over here and we highlight this area that contains the 4 and the 6, we can see that it clearly does not include A. It's like not A, not A, and not B, and not B. So nothing that is in A or B is included. So it's definitely the intersection. It is not A, it is not B, and the answer set is 4 and 6. Okay. Alrighty then. So here we go. This says that it wants us to find the complement, because this little apostrophe means complement or prime. So the complement of A intersected with C. So it means not the intersection of A and C. Okay, so earlier we actually found this earlier in our video. We found that the intersection of A and C was equal to the set of 3 and 5. So this little apostrophe means A intersected with C prime, or the complement of A intersected with C means not 3 and not 5. So if I go over here to my Venn diagram, it would be like not 3 and not 5. And that means that all of these other answers or elements would be part of my answer set for the complement of 3 and 5. So that means my answer set would be 7 and 1 and 2 and 4 and 6. Okay. And the next one that we want to do is going to be the complement of A intersected with B. So that means not the intersection of A and B. So let's look at this one quickly. The intersection of A and B is where it is in A and B. That means the overlap between A and B. So this area here is the overlap between A and B. So this little part is what's inside the parentheses here. But this little apostrophe means not that. So that means we would be like not this and not that. So that means that all of these other answers would be part of my answer set, 7, 5, 4, 6, and 2. So my answer set is going to be 7 and 5 and 4 and 6 and, oops, and 2. Okay, so I think we've put in quite a bit of effort in this video, and we're going to stop right there for today. But you have a great day, and we'll see you next time. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.